Today let us discuss some questions related to congruent triangles. Here you have two triangles and there are some equalities given. Let us find out what they are all about. You have AB is equal to AC. What does that mean? If AB is 10 centimeter, AC is also 10 centimeter. But then angles opposite to equal sides are equal. That means these two angles are equal. For example, if this is 40 degrees, this will also be 40 degrees. Next, what do you have? C is equal to P. There your C, there your P. Which means what? Your P is also 40 degrees. B is equal to Q. Here your B, here your Q. That means that is also equal to 40 degrees. But then what do you have here? Two equal angles, which means what? Their opposite sides are equal. I am putting two lines here. Why? Because these are the only ones they are equal. If this is say 10 centimeters and this will also be 10 centimeters, but then this does not have to be 10. All it has to follow is that it has to be equal. Say suppose if this is 15 centimeters, then this will also be 15 centimeters. If you look carefully, equality is given only for these two sides. These two are equal to each other, but then you don't have any idea, you don't have anything which connects it to this triangle. What you have is only the connection between the two angles. Is there anything you can do more? No. At the max you can find the third angle to be 100. That's all. Finished. Can you establish any equality between the two sides of these two triangles? No, not at all. It stops there. What you have is what? What you have is two isosceles triangles, but they are not congruent by any method. Why? Because what you have is three equal angles. When you have three equal angles, what you have is a similar triangle. There is no congruency called AAA, not at all. This is not a congruency. What this is similar triangles, not congruent. For example, they will look like this. One can be this big and the other can be this small. They will be similar, not congruent. So they are isosceles and similar but not congruent. You have two congruent triangles. Whenever you talk about two congruent triangles, you are talking about 6 equalities. 3 related to angles, 3 related to sides. How does that equality work out? First angle here, first angle here. Remember, it is very sensitive to order. You should not change the order. The first one here, the first one here. The second angle here and the second angle here are equal, which is D. The third angle here and the third angle here will be equal. There. You have 3 equalities related to angles and 3 related to sides. How will you find the side? First side will be, what is side? It is something which joins two vertices. So just take the two vertices together, AB and FD. If this is 5, it means this is also 5. How will you get to the next two sides? The next two vertices join together. This side and this side equal. Then the last one is the third one. It skips and goes like this. These two sides are equal. What do we have? If angle B is 40, then this is 40. If angle A is 80, then F is 80. Here says F is 60 degrees. That is not what we want. Look at the other two options. They are about angle E. What will angle E be? If this is 40 and 80, this will be 60. So what is your correct option? This is your correct option. This is about BE, about which you have no knowledge. So this is your correct option. Now look at this question. You have two sides of a triangle. You have to find what the third side cannot be. It cannot be greater than 6.5. It will always be less than 6.5. So find that one option which is greater than 6.5. The third side cannot be that. It can be anything other than greater than 6.5. Now look at this question. You are given two triangles and you are given only two equalities. For congruency you need three equalities, right? Now the question is, if you want it to be congruent by this congruency, by the SAS congruent theorem, then what should be your third side? Now look at this first equality here, AB is equal to FD. You have only two equalities given. So what you do is write down the names of the first one and adjust the vertices of the second accordingly. What do we mean by that? AB is equal to FD, which means F and D can come wherever. F can come here or here. How will we choose that? Look at the second equality. What does it say? A is equal to D. That means the place where A comes, that is where the place D comes. So this angle and this angle are equal. So AB is equal to FD, which means F comes here. There you have. So that just leaves the third vertex, which is what? It will come here. This is how your triangle is going to look like. Now we need SAS. Two sides and an angle between them. Here a side, here an angle. So this is what you are looking for. Two sides and the angle between them. So what you are looking for is AC equal to DE. Where do you see that option? Here. Now look at this question. You are given two equal sides. Whenever you are given equality or inequality related to the sides, remember their opposite angles follow the same equality or inequality. It will be exactly the same. What is the opposite angle? What is the only vertex which is left out from here? Angle R. You have an R and P. What is the only vertex which is left out? Q. Now I have written equality here. Remember, the inequality will also be the same. Now remember, whatever relates to sides, equality or inequality, remember their opposite angles are also bounded by the same relation. Look at this question here. You are given two parallel lines, AE and BC. These two lines are parallel. The minute you hear the word parallel, remember all of these wonderful figures. These three will give you equal angles and these two will give you angles which add up to 180 degrees. So remember them and we will see where we are going to use it. Now what is the other condition that you are given? Other information, AB is equal to AC. So if you consider them as two sides of a triangle, you will get what? Their opposite angles are equal. If one is X, the other will be X. Then naturally what will be the third angle? The third angle be? It will be 180 minus the sum of these two, which is 2x. This will be your third angle. Now we said these two are parallel, right? Do you notice a Z figure here? If this is X, its alternate interior angle here will be X. Now what do you have? You have a line split into three angles. So added, they should give you what? They should give you 180 degrees, and 180 here, a 180 here, equal terms cancelled. So you get 70 minus X is equal to 0, which means X is equal to 70 degrees. But that is not your question. You have to find what ABD is. If this is 70, this will be 110. There, that is your answer. Now look at the question here. You have two squares. One is a bigger square ABCD, and from a point in the interior we are constructing another square, a much smaller one. What is its name? AXYZ, and two measurements are given. One is this measurement 2. Then what do you know? If this is 2, then each one of them is 2, right? Why? Because it is a square. And then another one measurement is given. What is it? DY is given as what? 3. Two measurements given, and the third one asked for. What is it? It is BY. you have to find what by is. But just looking at it, what do you see? It is bx plus xy. Now what is xy? It is already given as 2. All you have to do is find bx. Won't it be enough to find just AB? Why is that? Look at this angle, it is 90 degrees. Why is it 90 degrees? You see AZYX, that is a square, which means it makes a 90 degrees here, and that means this side will also be 90 degrees. But remember, this whole A is 90, not just a bit of it. You don't know what this angle is. It is just a bit of 90 degrees. So you will not take this angle as 90. Instead, you will take this whole angle as a 90 degrees. And what do you have? This small angle here, AXB. Its one side is known, which is 2, and one angle is known. All you have to do is find this. Then you can apply the hypotenuse, the Pythagoras theorem, and you can find the answer. But then how will we find AB? There is nothing, no other information given there. So come to this side where there is lots and lots of information lying. What do you know? This side is 5. This side is 2. Again, what do you see? A right angle triangle. This time your right angle is formed at this place, which means what? Its opposite side is the hypotenuse. Always the side opposite to the right angle is the hypotenuse. So you have a nice little right angle there. ADZ, the square of AD is equal to both of this. Here you have a 2, here you have a 5. Together its square is what? 29. But then AD and AB are equal, which means what? If this is square root of 29, it means this is also equal to square root of 29. Now see, again you have got two sides. Then what do you have? You don't know what this side is. How do you find it? Again apply the Pythagoras theorem, but this time your right angle is here, there. When you apply it, you get what? XB is 5, or in other words, if this is 5 and this is 2, together they give 7. That is your answer. Look at this one. You have this figure here, and wherever you see an angle, you have to find the sum of all of them. Very easy, right? It looks like a complicated picture, but what is it? It is just two triangles put together. So the angles of one triangle, 180, another one, 180, all of them together, 360. Now we come to the last question of the day, and with this we will cover our revision as well. What you see here is 4 basic criterion for congruency. Either you have two triangles with all the 3 corresponding sides equal, or what is the second one? 2 sides and the angle between them, or 2 angles here and the side in between of them. The fourth one is RHS, which means right hand, hypotenuse, and a side. Side can be any side, but you need a hypotenuse for sure. If you want to apply the RHS rule, you need the hypotenuse for sure. These are the 4 criterion for congruency. Now what does congruency mean? What do you actually put it in, like in everyday, how would you understand it? If you take this triangle and put it on another one, it should completely cover that. So that is what basically, in basic terms, that is what congruency means. But then mathematically, this also means another thing. This much information should be enough for you to construct any triangle. If you have a triangle, how much information do you need? There are 3 angles, 3 sides. You need 6 terms. You need to know what are 6 values for you to construct a triangle. But then it is not so. If you have any of this, that is enough. You don't need all the 6 angles. You just need 2 angles and a side between them, or 2 sides and an angle between them. Any one of these information will be enough for you to construct a triangle. But often you will see that this AAS criterion is also used. Why? Because this ultimately leads to ASA. How? Look at this picture. There you have a 40 here, a 60 here. You know two angles, but you have absolutely no idea what the angle in between them is. So you cannot, technically this is not ASA, right? But then if this is 40 and 60, it means this is 100, which means this is 100. Now what do you have? Two angles and a side between them, or in other words ASA. So often this leads to other. So you can also consider as a fifth congruency. This is also fine. This is your sixth congruency. So this is what the law of congruencies mean. What is not the correct answer? There is no ASSA. This is correct. Why? Because this leads to ASA. So this is correct. This is your wrong answer. And now another one thing which I want to mention is that now I have often seen students get confused between the RHS and the SAS congruency rules. This is a big problem, especially when it comes to multiple choice questions. These are not the same. What is the difference that you notice in these two conditions? You have a right angle, you have a hypotenuse, and you have one of the sides. But what is this? You do not have a hypotenuse here, because the minute you see a right angle, we just think that it is going to be RHS, but it is not. What else do you need for the RHS criterion? You need a right angle and you need the hypotenuse. What is the hypotenuse? It is the side opposite to the right angle. You need that to apply RHS. But you see this, it is a right angle, but it is SAS. Why? Because you have two sides and the angle between them, you do not have the hypotenuse. So you cannot apply RHS here. And similarly here, you cannot apply SSA. There is no such congruency as SSA. You see what is happening? You have an angle. From there you went to a side, but then you missed the angle here and then you jumped to the other side, which means this is what you have. There is no such congruency. Now I'm sorry, I said I was going to finish with the last question, but seriously I'm going to finish with this one. Please look at this. The reason I included this is that I see students making lot of careless mistakes when it comes to this type of questions. You see what we are given? We are given three equalities. Always draw the first triangle and adjust the second one according to this. And which one will you take first? There are sides and there are angles. Which one will you take first? Always take the angles, because with the angles you are dealing only with one vertex, but when it comes to the sides you are dealing with two vertices. Which one corresponds to A, you will not be able to know. A can correspond to D or E. So angles, always start with your angles. You have what? A and E are what? Equal. Now see that AB is equal to DE. You already know that A corresponds to E, which would mean what? B should correspond to D. There. This should be same. The third one is what? AC. What is left? F is left. So just write it there. Then what do you have? AC is equal to EF. There you have your two triangles. Then ABC. How will you write it? A and B and C. A corresponds to E. Then you make the same journey here. D and F. This is here the correct way the congruency works, which is what? It is this one. Is the congruency criterion correct? Two sides and an angle between them. So this is your correct answer. That's all for today. Till I meet you again. Assalamu alaikum.